Hello, hello all. So happy Pongal, all of you. I think today is the last day of the Pongal. The Pongal, Matu Pongal, somewhere it's Kanum Pongal, then all days fall together. So this is usually like when I was studying school, a continuous 4 day or 5 day holiday is Pongal. Usually is a happiest part of January, along with it's like a 3 months we get like continuous holidays, following with Christmas, Diwali, all this like continuous update on the trip, along with the rainy days as well. Okay, so welcome to Vaayusastra Aerospace Future Scientist Meet, chapter number 42. So those who are watching it for the first time, so let me introduce Vaayusastra. Vaayusastra is an IIT incubated startup spreading awareness of aeronautics and aerospace among school children and college students using storytelling methods, hands-on models, and we are creating a unique curriculum for children and college students. And we still did we created a lot of sparks in the sense we created. If you go to Vaayusastra page and look at the Hall of Fame, you can find some of the results we have created. Yeah, that's what we do. And today, let's start. We have three presenters who are going to do their research work today. Uh, Riyansh, Kashika, and Naman. So all these are familiar faces who are like following Vaayusastra regularly. Because all these might have definitely presented more than 40, 30, 40 topics the presentations easily. Before even starting this, they started, they were continuously presenting. Okay, the first presenter of the day is Kashika. So Kashika is currently doing her level 5 in Vaayusastra regular programs, and she has done all the 9 levels in our Trigger the Spark module, and she is a grade 9 student from KV, Kendriya Vidyalaya, Ashok, Nagar, and she is going to present on this topic, comet bernardinelli. Okay, so I can see on Einstein and some Bernardinelli. Okay, to know more about this topic, I like Kashika. You yourself, please reveal what is it.
Yes, sir. So I know the name itself is very complicated to say, comet bernardinelli bernstein. But I'll also say how this very complicated name came from. So let me start off with my presentation. Right. Hope you can see my slides. Is it visible?
Not yet. Yeah, it's visible.
Okay.
Screen is loading.
Yep, you can see my presentation.
Yes, I can see.
Okay. So this time I tried out with Canva just to see how the presentation goes. So welcome to the presentation, and this is a very interesting topic. How many of you kind of are addicted to seeing comets and comet hunting? There was this comet Leonard which came recently, and last year there was comet Neowise. So how many of you have seen this comet? Went out and done the observation. Anyone?
Yes, I'm. Internet is back. Yes.
You can raise your hand. So if not this particular topic, Comet Bernardinelli Bernstein, I don't know how many of you have seen this movie. It was like recently uploaded. Don't Look Up or Just Look Up. I don't know, some movie. But it's about a comet coming and hitting the Earth. It was like a 10-kilometer wide comet that is about to hit the Earth, and it's going to like planet killer comet which will destroy the entire humanity and stuff. But this is sort of similar. But the thing is that it's not going to hit the Earth or something like that. It will not even come so close to the Earth as well. But this particular comet is
Anish
still.
has seen this.
And check
In
the
the
chat.
chat box, I can see Anish.
Oh,
He's
okay.
seen the movie.
Right. In the chat box, I can see that. Right, Anish said that he has seen the movie. Exactly. The movie, it kind of says that it kind of come. Yeah, black comets don't even hit the Earth. Probably not until we have seen, but we definitely know asteroids do hit the Earth, and that's why the dinosaurs are gone. So, but in that particular movie, they have said that a comet is going to hit the Earth. But this particular comet, it is the largest comet. It is the largest comet that has ever been discovered. But we don't. It will definitely not hit the Earth and destroy the entire human civilization. But it will be the biggest comet that has been ever discovered to date. And this is kind of an exciting. This discovery wasn't, an ancient discovery. It was kind of a recent discovery that happened. Um, so let's move on with the presentation and see and learn more about this particular comet. And don't get confused with the GIF or GIF I have put right up here in this presentation. It's actually a comet nearby, but this comet Bernstein will be very, very, very faint. So before I start the presentation, I want to make it clear that you won't be able to see comet Bernstein with your naked eyes, even at its closest approach to Earth. So its closest approach will be in 2033 or somewhere around there. That's what like predicted. What scientists have anticipated that that's when the closest approach will be. So this particular comet won't come and hit the Earth, and you won't be able to see it with your naked eye. So I want to make that clear right now. But this is still a very interesting discovery and very crucial evidence for the scientific field itself. So before I start the presentation, what is a comet? So what do you think a comet is? And I know the answer is right over in the slide, but I still want to hear from all of you that what do you think a comet is? Anyone? You can put it in chat as well.
What is a comet? I think all of you may be knowing. We had a separate session on comet, asteroids, and meteors.
Yes, we did.
You can answer. Yeah, I can. Few answers are there in chat box.
Yeah, Ria has answered that comet is made up of rocks and ices. That's very true. And anyone? Anyone would like to give it a go? And it will be very fast. So comets, so I know the answer is right up in the presentation. Comets are left over from the formation of our solar system. They are composed of dust, rocks, and ices. It's the basic definition. But comets are also known as dirty ice balls, particularly because that as Riya said in the chat, that it is made up of rocks and ices. So basically, it is also made up of dirt. That is like they are also known as dirty ice balls because they are the debris. It is made up of debris of the solar system. So it is made up of icy particles. So it's everything in there, and the comet is frozen. So it's particularly frozen. So that's why it's known as dirty ice balls. So I want to make sure that you also get that word right there. And what is the anatomy of a comet? What a comet is made of? And he has said that it has a very long tail as well. That's very true. But the interesting fact is that a comet actually has two tails. It actually has two tails. One is the ion tail, and another is the dust tail. So, and that's parts of a comet. And this ion tail and dust tail won't develop until the comet comes closer to the sun or its heat source. Um, Comet definitely has a coma and then it has a nucleus. And I want to tell this particular interesting fact when a comet is really far away and a scientists are trying to observe it from Earth using the telescopes, right? They actually miscalculate this entire coma. Just like if you can see this entire coma as the nucleus of the comet, but particularly the nucleus will be hidden inside the coma itself. But when they're really far, scientists kind of miscalculate sometimes that the entire coma itself is a nucleus. That will lead to the miscalculation of the size of the comet. This particularly happened with comet Bernardinelli, but it's still to date is the largest comet that has been ever discovered. Right. And let's go further and discuss about what do we see here. So what do you see here? I want you to observe this picture, and I want you to tell what do you observe in this particular picture. You can put that up in chat, or you can just unmute your mic and speak. Stages of a comet, that's particularly very true. And anything else? Anyone? Or comet rotating is. So I think Riya has answered it. But the particularly interesting fact is that you might notice as the comet is coming closer to the sun, the yellow wall you see in the middle in the first picture with the really bad quality. The picture quality is really bad. I'm so sorry, but as you see the center yellow ball, it's the sun, and the comet, which is particularly from that's like right here. The comet is right there. It's like a rock, right? But it gets closer to the sun. The coma kind of develops, and it kind of comes closer to the sun, closer to the sun. And at first, its dust tail develops, and then it comes its ion tail develops. So, and as it gets again, it goes away from the sun because comet has a particular orbit, right? Like the planets do, they come around the sun in a periodic manner. But there are also non-periodic comets. So, like the comet Leonard, it was a non-periodic comet. And periodic and non-periodic comets basically is periodic is that it will have a occasional it will have a periodic visit. That means like comet Halley's it will come like every 75 years, right? Something like that. So it will have a correct time span when it will visit and when it will go. But non-periodic comets, they definitely won't have a particular time that they will come this time and they will go this time. You know, they can come and they can leave. It's their wish. We can't bother with that. So this is particularly like this comet as an orbit, and when it gets closer to the sun, it definitely and Darsha said it's orbit of a comet. That's also very true. It is the orbit of a comet as it gets closer to the sun. It evaporates and it starts to evaporate and develops tails and stuff, and it gets away from the sun. Its tail again, you know, kind of decreases. But I want you to notice here. I don't know if it's very visible in this picture. The comet size would have reduced every single time as it orbits the sun because every single time it's leaving some materials out, it's ejecting some materials out, right? So as it every orbit from the sun, its size will reduce. I want to make that clear. And yeah, why do comets have tails? Why do they have tails? As I said, they get closer to the sun and they evaporate and they form two different tails. But I want to go on a little more deep and speak about why comets have two tails. So one is made up of dust particles, and the other is made up of ions. To particularly say what ions are like charged species. They contain some charge, positive, negative, and so as I said, the tails get as they get closer to the sun, they develop tails. So usually tails are always away from the sun. There is the gas tail, which always points straight away from the sun, and the dust tail, which actually curves away from the sun. I want you to notice here. So this dust tail, I want to so I've given the definition. So two tails are there: ion tail, which usually directs away from the sun, usually has a straight direction away from the sun. But this tail, what happens is that it curves its orbital path. It has a curved orbital path. And in this particular first picture, I want you to tell me that which is ion tail, which is a dust tail. Any guesses? Like there are two tails. There's one blue tail and there's one yellow tail. I want you to tell me that
Yes,
which one.
Anish, tell. Anish. Anish.
Yeah, Jago. The yellow one, the yellowish orange one is the dust tail, and the blue one is the like the what is it? I forgot its name. But
Ion tail.
Yeah, tell. Yeah.
Ion tail. And exactly, that's correct. A big round of applause. And the particular way, if you don't know how Anish found out, as I said, dust tail kind of has a curved path. You know, the tail kind of curves itself. So if you notice this yellow one, it is curved, right? It's a little bit curved. And but the blue one, it's always straight. I don't know if you can notice, but you can see it's actually the yellow tail is slightly curved, and the dust tail, the ion tail, which is the blue one, it's straight. So that is kind of a difference how we can make. And I'll talk about the two types of tails. So one is charged. So the charged particles usually they are directly away from the sun. I hope you got that difference. And another thing is that where do comets come from? And I have put a couple of pictures here, but I don't want to put that put you. I want you all to put that in the chat or just open up your mic and speak. Where do you think the comets come from? Anish still has the answer. You can speak.
Oh, I forgot to raise my hands down.
All right, that's fine. Anyone? Any guesses that where
Where do the comets come from? Comet எங்கிருந்து வருகிறது? சொல்லுங்கள், boys and girls. Just guess.
Right. We have said Kuiper belt. Anyone? All right. And there's one guess. It's from Kuiper belt. That's correct answer. That's obviously the one of the correct answer. So it do mainly come from Kuiper belt, but the main origin that I would say, if we extend the idea a little bit further, is that we say that there is a Oort cloud. Oort cloud is kind of the boundary of our solar system. So you can see this blue dotted or kind of line, this one, and this is particularly, it is the Oort cloud. And Oort cloud kind of margins the boundary of our solar system. So if you can see this particular sphere, this we say is the Oort cloud. And people think that from the Oort cloud, the comets come to the Kuiper belt, and then from the Kuiper belt, it comes to our planetary region that is closer to the sun itself. And that's where comets come from. They come from the very farthest reach of the solar system, and they are very cold. Those farthest reaches are very, very cold, and that's why comets are usually ice. That's why when they come closer to the sun, they evaporate, because if you take an ice cube out of the fridge, it will eventually become water. That's because it's getting evaporated. It's the same thing happens when, like, just think that this Kuiper belt is the fridge of the comets. So imagine the comets are the ice cubes and the Kuiper belt is the fridge. And when you take the ice cubes, that is the comets, out of the Kuiper belt, in here we say it is the fridge, and when it comes out, it will eventually evaporate as it gets closer to the sun. Right, and that's where the comets come from. And now actually, let's enter the king of our topic. And I'm going to mute my audio now. Okay, I just want you to notice the picture. I just want you to see the image and the video. So let's come to the king of our topic. It's the main focus of the topic. That is comet Bernardinelli 1 instance. And I'm going to reverse this video for a minute. Let's go back a little bit. Sorry. Okay. Let's start. Okay. I want you to notice this particular video very carefully. And as it gets closer to the sun, this particular rock, as it gets closer to the sun, you can see that a dust tail will eventually start to come out. That's basically the ice evaporating. Just want to notice there, just how the dust is coming out like dust particles. And as it gets closer to the sun, the ionic compounds come up. And the red one, that is the ionic tail. As you see, there's two tails, and it has crossed Mars and stuff, and it gets closer to the sun. So this particular topic that we are talking about is comet Bernardinelli 1 instance. It won't come so close to Mars and stuff, but it will still be in Saturn. It will still be in the orbit of Saturn. So it will just come that close and then it will go away again. So that is its closest approach. That's why you cannot see it with your naked eyes because it's already so far away. So it's kind of the exact thing that people have assumed that this particular comet will look like the one in the video. So I got the best wishes that I could get. So I can give you a speculation on how the comet will eventually look like. So this is the find of the decade. So this eventually is the find of the decade. So this particular comet was discovered in 2014. 2014, yes. And this was the largest ever icy body that has ever been identified. And this was made using the dark energy survey. And this survey was particularly, as the name suggests, it was used to find dark energy and dark matter. So, but the scientist kind of while searching the dark energy, he was using the data from there. But then he fortunately discovered this comet. But we'll go to the story in the upcoming slides. I just want you to know this. I just want to get the fact that this is the largest ever icy body that has ever been discovered, the largest ever comet. The good thing about it is that I'll discuss further in the slide. There is a very interesting fact about it that astronomers are very eager about, and the revelations are on the way, which means that the tail, which is really far away from the sun, so it gives an astronomers an excellent opportunity. That's because so for example, we haven't ever discovered a comet which is really that far away. Comet Bernstein is 25 astronomical units away as of now. So it's really far away. So it hasn't even developed a proper coma yet. So what scientists are very curious about, where astronomers are really curious about, is that as it gets closer to the sun, as it gets closer to the sun, they'll be able to see how the entire coma, the tail, and everything develops. So this particular thing that has been never done before. No one has ever seen how a tail develops or how a comet comes closer to the sun, and it's, the entire evolution of a comet. None of us has seen it. It's like seeing a person from the birth and seeing him till he is dead. So like the complete evolution, complete lifetime of a comet. So even though we haven't seen it as the rock has formed, from the earliest phase of the solar system, but this is an excellent opportunity that has given to astronomers. That is, as the comet gets closer to the sun, we need to see how the coma develops, how the tail develops, how the comet's dust tail develops, how the ion tail develops, what kind of matter, what kind of gases is inside the comet Bernardinelli. For now, they have sensed that it might be carbon monoxide. For the fact is that the comet has a coma, which we'll discuss further in the slides. Anyways, so let's give some credit to these amazing discoverers. And now you know where these weird names come from: Comet Bernardinelli and Gary Bernstein. So, I'm sorry, Peter Bernardinelli and Gary Bernstein. So they were the discoverers, and the comet name came from their last two names, last names, Bernardinelli and Bernstein. So, these particular discoverers, and uh,
Kashika, you are muted. Hello. Kashika, you are disconnected. Hello.
sorry, I think there was some connectivity issue. Right, let's continue. I'm so sorry. So, these were the two discoverers, Peter and Gary. Let's look at these faces so closely because it was so hard to find these two people images. They were not anywhere. They were not very easily found on the internet. So let's talk about these two unlikely pairs of scientists. So first, Peter Bernardinelli, who, for instance, his field of expertise was trans-Neptunian objects. He wasn't kind of a comet discoverer and stuff who hunts comet, but his field of expertise was trans-Neptunian objects. So if you don't know what trans-Neptunian objects are, they are particularly objects that are beyond the orbit of Neptune. As you can see, this is blue. this is planet Neptune, I hope that is identified, and everything beyond here is trans-Neptunian object. And here we have Neptune again, and everything that's beyond the orbit of Neptune is a trans-Neptunian object. Right. It's and there's another discovery, right? Gary Bernstein. So Gary Bernstein was particularly the an advisor of Peter Bernardelli. That's basically what Peter Bernardelli, he has just completed his PhD, so he was kind of the advisor. So as soon as he knew, as soon as he did this discovery, and yeah, as soon as he did this discovery, he didn't know that the discovery was actually right, or there has been some distortions in his data or something. So I will get to the story later as well. But Gary Bernstein, his field of expertise was to see distortions that has been caused by dark matter. So that's an interesting. Yeah. The distortions that has been caused by dark matter. Let's see. Okay, the story behind this discovery. So the story behind this particular discovery is that so one early observation was that he used this data from dark energy survey. So what happens is that when there is a telescope right here on this planet, right here on the planet, a ground station, so the telescope, a ground telescope. So what happens is that when it takes the data which is in the sky, deep space, it actually collects the data, everything in between it as well, like the atmosphere, the airplanes, the planets, everything. So it actually captures everything that is between the telescope and the object it's trying to take. So what happened is that while taking the data, while using this particular telescope, and he was actually taking the data to find trans-Neptunian object, but particularly he saw that this particular comet, this particular rock or dot in the data actually here, right there, it came up very periodically, like it wasn't like a coincidence. So for instance, how to explain this is that um, he first saw the image, and then he saw this particular comet, and it was moving. After stacking the images, it was moving, and he just thought it was some sort of distortion in his data. But then it came up very periodically. It came up again and again after stacking about 30 stacks of images. And he knew this wasn't a kind of a coincidence that happened. So, and the next thing that he did is that he went to Gary Bernstein, and then he saw his he told about this discovery to his advisor, and then they both made this discovery. So, and now this, we have to give some credit to this particular telescope or survey, dark energy survey. So what happened is that, as I said, this is where they got the data, and this was the data that was used to kind of to get the actual data for the discovery of this comet. And this particular telescope was an international collaborative effort. It mapped millions of galaxies. And while mapping these millions of galaxies, fortunately, it gave us the discovery of finding the biggest ever comet. So actually, an interesting fact is that these two discoverers, they actually wanted to name this particular comet as Dark Energy Survey, but it was against the rules. They couldn't name it Dark Energy Survey. So if they have named it, we wouldn't have to spell this very complicated name as well. So as we connect the dots, this particular comet turned up in 20 to 30 separate images, and they knew this wasn't a coincidence, and they made the discovery. Right. Um, and there was also one particular person who played quite an important role in this comet. And so when the comet was discovered, we didn't get a very good image of the particular comet. There is the comet Bernardinelli. So Tony Fallon, what he did is that he took the images. He took the images of comet Bernardinelli from 2014 till 2016. I think. No, sorry, 2014 to 2015. Sorry, 2015. So he took this image from he took this image for the periodic time from 2018 to 2020. So what happened is that after he stacked those images, after So how particularly scientists do that is that they take an image from 2018 and then they take a periodic image. They take a frequent images of this particular space, this particular comet. So and then they stack up these images in order, and that's where they get a clearer view of this comet. And this is the best they could have done. So, this is the best that you know. This is the best because it's so far away. It's so hard to predict something that far. Um, so Tony Phantom, I don't know how many of you are here that are Marvel fans. So it kind of sounds like Tony Stark. And then I put up the marvel of transiting exoplanet survey satellite just to make sure make the connection. Right. Anyways, this particular data that he got from 2018 to 2020, it was from the TESS observatory. It was particularly used as a name test. It was for exoplanets. But then again, if you send up a space mission, it doesn't have to be used for one particular reason. It can be used for a different particular reasons. Right, let's talk about its closest approach. Let's talk about when it will come so close to the Earth, when it will come so close to the Sun, can we see it or not? So its closest approach will be in 2031 or 2033. It's just speculations. So this particular comet will have its closest approach around in Saturn. It will be around the orbit of Saturn. So we cannot able to see it with our naked eyes, but its closest approach will be 2031. So if you still remember this presentation, if you still remember the topic that we discussed today, and if it strikes back you in 2031, make sure you go and visit this comet with your telescope, or just go to some YouTube, and they'll have thousands of webinars going on. Right. We have. So this particular comet is actually very active. This has a coma around it. So why it's very unexpected is that this comet is actually very far away, 25 astronomical units away from the sun, but it still has a coma around it. So that's why scientists have speculated it has carbon monoxide around it. Basically, because carbon monoxide evaporates quicker. So even it has little less heat, it will still evaporate quicker. So that's why they have speculated that it might be carbon monoxide. So it has a coma around it. This is very unexpected. And I want you to know that what's so special about this comet that I made this entire presentation about. What is so special about this comet is that exactly we haven't seen an evolution of a comet. We haven't seen how the tail forms, how everything comes from the start to the end. So this comet will give a very excellent opportunity since we have made this discovery very early on. So that's the thing that's very special about this comet, other than the fact that it's the biggest comet. So to give you the taste on how big this comet is, I want to do a size comparison on it. I have a little question. Which is the biggest mountain in our solar system? Any guesses?
Olympus
All of you.
Mons
And where is it?
in Mars.
Right, it's on Mars, Olympus Mons. And this is Mount Everest, this is Grand Canyon, and this is Olympus Mons. This is so big, and this comet is 5.5 times longer than Olympus Mons, and then it's 3 times wider than Comet Hale-Bopp, which was it kind of gives us a very spectacular vision to Comet Hale-Bopp. So I want you to imagine the size of this comet. If this comet lands on planet Earth, we are all destroyed in a fraction of a second. But it won't. It will just be in the orbit of Saturn. Right. Just want to give you size comparison. Now, I don't know how many of you have observed Comet Leonard. Has anyone observed Comet Leonard? Because it was right there, close. And I just wanted to see. I just want to know how many of you have seen this comet and went outside and saw this comet. Right. Anyone? Right. So if you're not sure, this comet Leonard.
Anish raised his hands.
Oh, Anish, if you have seen this comet, it's very well because I missed it as well. And if you have taken some pictures and stuff, send it over. And this comet Leonard, it was right over here. It was very near. It was kind of, it has its closest approach. People were seeing it and stuff. But also, I want to introduce you all to this particular website. If you're in your laptop or phone, let me show you this. I'm going to share my screen again. I'm going to stop share and share again. There's this particular website called skylive.com. If you're on your Chrome tab,
Can you share? Can you send the link so that we can use it?
Just go to your Chrome and then click skylive.com. And there's so many options here. You can just see how to see this in your solar system and the night sky, and there's a 3D solar system simulator and stuff. But here, what I'm interested is the comet Leonard. And I'm going to click on comet Leonard here, and let's go. Let's wait for it to load. Right. And I have already updated my location, that is in Chennai, and there's a typo here, but it's fine. If you're in any other location, just go on and change. I can change the location if I'm gonna type Chennai again. Chennai something. Okay, submit. And if you have selected your location, and now let's go down and let's see the visibility. And okay, if you go above right here, and it just give a little information about the comet itself. So this is in the constellation Pisces Australis, and it's in the right precession of the comet is in right precession of comet Leonard. And you have the assertion and declination that has been given right here for you. And the magnitude is 5.8, which is very low. So one thing that is that when the comet is in negative part, that is when it's brighter. If it's on the positive side, it's still lower. Okay, right. So visibility right now, it's actually below the horizon from Chennai. So it's easily visible with a small binocular, but if you're in a very dark place, just see this given its current magnitude. There is comet Luna is easily visible with the help of a small binocular, unless if you're in a very dark location. You can see the rise and set time, and if you're seeing for any other date, if you want to do your observation somewhere on Monday or something, just click Monday and give your time here. It's in UTC, just convert your time zone. And this is Leonard, you can see it right here. But also I want to show you this simulation that's right there. Give me a second. So meanwhile, I take out the simulation. I just go and explore with the site for a little bit. I'll just take out the simulation right now. Stop share and share again. So I put the website link right over here as well.
I will share it on my
I'm sharing my screen again. So I put the website link again. Let's go and click skylive.com. That's all you need to put. Put that in the chat as well, and you can find it in your YouTube chat as well. All right. So comet. So as you can see, this is the orbital path of comet Leonard. I'm gonna go up a little bit, and this is the Earth. It's actually very far away from us now, so it's kind of here. But I also want you to see it's if we go on a little towards December, you can see that the comet, the position. If I go to January, so the comet has already traveled from here to here. But if I go to December of that means 2021, the comet was really close. If you have missed the chance to see it, I'm so sorry. And let's go a little to November again. The comet is actually gone. Yeah, it's actually above this point. So December was like the perfect opportunity to see this comet. But if you're still, if you're still very in January, it's still visible, but you still need a microscope and you have to go to a very dark place. And that's right, the comet is right here. And so you can actually change the time as well. You can see how the comet will. This is like the orbital path of the comet. So just to show you the orbital path. And I want you to notice this line. That's just this particular faint line, the one that's red right now. Right, the one that's red. As you can see, the comet came from the farthest reach of the solar system, and then it's right over here, and then it's again will go away. So it's on a journey to go away. So let's go and experiment a little further on. Let's see what will happen in the next month, February. It's again move further, and then on March it's again move further. So and on April move further again, and May move further, and June, and then I'm just gonna click see. You can actually see the orbit of every planet in solar system. That's right. So again, on April 2024, it's still there, but you will not be able to see it. It's going to its orbit again. So you can experiment whatever you want. So for instance, I'm gonna put any other object. Let's put comet nearby. Or any other suggestion that you have? Any other comet suggestion that you have? We can see, or any other planetary. Let's see comet Halley. Let's see comet Halley is there. So let's see where it is. So comet Halley, it's right. Okay. Comet Halley, it's right over here, and you can just experiment with this website whenever you want. So I'm on it. So I'll give a link to this website. You can go. I already said just go skylab.com and then click any simulation that you want to see. So okay, fine. So let's come back to the presentation now, and I have a little more things to show you. I hope many of you are familiar with these apps that show you this astronomical observation stuff, like Stellarium. There was another one, Starwalk 2 and Starwalk 1. These are like popular apps that people use to see the astronomical figures. And I wanted to show another thing as well.
Kashika, you told skylight.com. It's not coming from me. It's telling you need to log in.
Oh, you don't need to log in. Okay, let me share my screen again.
Oh, got it. Thanks. Because I want the link only.
Okay. It's okay, fine. I hope you got the link now. Ray has posted it anyways. If you don't get the link, I'll put it in WhatsApp group as well as in the YouTube live later on. So this comet Bernstein, the observation report and viewing circumstances is long gone, but you can still see it with the binoculars and telescope in a very dark place. Let's also take a little look on the famous bright comets. Like we have the Helios comet, which was spectacular, and a lot of people saw it 75 years ago. It was amazing. And there was a comet Pan-STARRS, which is also known as C/2011 L4. This was on another famous bright comet. And we have is on comet C/2012 S1. You can research more about this comet as well. And I just want you to see how to observe a comet, or just how to observe any astronomical body actually. First thing that you have to do is that travel to a remote dark location. If you live in city and you don't have a very good place, very good sky, or a very dark sky, first thing you can go to a remote dark location. In Chennai, maybe if you're closer to Chennai, you can go to maybe Elagiri or somewhere like that. It's a very remote place, like a hill station. And first thing is that when you go to your dark place, first don't use any white lights, don't use any sort of light actually, and other than red color light, which has a very shorter wavelength, and it kind of helps you to adapt your eyes to the darkness. So and then first you go there and then adapt your eyes to the darkness, you'll be able to see the difference. In the first 5 minutes, your eyes will be able to gather few light, and then the next 10 minutes, your eyes will be able to gather few more light. So in the next 20 minutes, you'll be able to see more light upcoming from it. You can actually observe, you can pick up more light from the night sky itself. So first thing, travel to remote location, next adapt your eyes, and then use a binocular or telescope, whatever you have. But the first telescope of human being is your eye. So use your eye first, and that is the greatest resource. That is the greatest telescope that we have. And we have come to bibliography. But before I go to that, I just want to show this again. Stop share and share again. Right. I wanted to show this. I know many of you have seen Stellarium, the app version, but I also wanted to know that there's a web version of Stellarium. Just go to your Google Chrome page and then type Stellarium, and then I already copied it. You just come like this, stellariumweb.org. I'll post this in the chat as well.
Kashika, your screen is blank.
Oh, is it?
It's fine. It's fine.
Now it's fine.
Okay. So I just go to stellariumweb.org and I'm gonna click on it. And you don't have to download the app if you don't have the premium subscription. It's just, if you have it on the app, if you have it on the web, it doesn't really make a difference. Just go to stellariumweb.org, and now it's actually blank loading. And if you have the app version as well, I'll do a little show on the app version as well. I think I haven't checked the chat. Just one minute. Okay. So the Stellarium web is starting in. So I have set again, my location is put up as near Chennai, and you can set up your location. Just go here, click, and then they will show a location dialog box, and then you can click your location. And then there's time and time setting zone if you want. You can adjust your time here. I'm still in Chennai. I'm sure it's Chennai. It's just right. Okay. We have the time and date. You can change the date. You can change the date here if you want, and you can change the time here. I'm gonna go further into the night, and it's around 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock. So tomorrow around 6 o'clock, the sun is about to rise, and then can blank again. So it's around 12 o'clock at the stop. So again, if I go back in time, so from 12 o'clock, you'll be able to see from here. So, and then again, the entire evolution of first the moon will come up here, and then slowly as the sun fades away, you'll be able to see more and more. You see the beauty of the night sky. Everything okay. You're not sure what this is. This is the Pleiades cluster. It's, as the name goes, it's like an open star cluster. You'll be able to see it, and I think Pleiades star cluster is one of the greatest sights they can see. And also, if you click on this constellation button, you'll be able to see what constellation it is. And if you see constellation R, if you click on constellation R, you'll be able to see if what Asa Major actually is. It's like a bear, and then Draco is like a dragon, and Brutus is like a man. The snake and the bow, the thing right there. And if you click on atmosphere, what happens is that it will remove the atmosphere. As we know that atmosphere kind of takes up the most of the spectrum, the light spectrum that's coming from the star. But if you click remove atmosphere, it will kind of remove the entire atmosphere around you and will show how actually the sky would look without an atmosphere. Without an atmosphere, this is how actually the sky would look. But with an atmosphere, this is how it will actually look. Just see the difference with atmosphere, without the atmosphere. How dark and beautiful the sky is without the atmosphere. But unfortunately, without the atmosphere, we cannot live. So, and then you can see the landscape. If you can remove the landscape, that means you won't have any sort of landscape. But I think the landscape kind of helps to differentiate below the horizon and above the horizon. and there's the azimuthal grid and equatorial grid, and then we have deep sky object, which will be pointed. Deep sky object is that which is really far away. That is in the deep sky. So if I click on night mode, you'll notice that it instantly goes all red. That is usually because when you go out to the night sky, when you go out to do an observation, as I said, you cannot use white light. You cannot use your mobile torch, or you cannot use this white torch light or something. You have to use a red light. You definitely have to use red light, because that won't obscure your eyes. It won't expand your pupil section, so that your pupils can absorb. It can take up more light in the night sky. So if you're doing an observation, and I would always suggest you go on and click the night mode. So that's all that I had to share. And
quiz.
Yeah, quiz, coming up to the quiz. Give me a second.
Nice, nice. So this is like a mini master class, not mini, actual master class for those who are enthusiastic or learning about comets. So it started off, it's like a single comet, but the content is like it covered almost everything, every comment. Nice, well done, Kashika. Well done. So at the quiz, okay, let's finish quiz then.
Actually, I want to make the quiz a little more interactive. Instead of Kahoot or something like quiz, something like that, I actually wanted to give out a quiz like in the presentation itself.
Nice.
Like if you know the answer, you can put it in chat, or else you can raise your hand and then you can say the answer. Anything is your choice. Right. Let me go ahead.
Okay, quiz time.
Comet Bernardinelli Bernstein was discovered by option A, Peter and Gary, option B, Jerry and Austin, option C, Jane and Austin, option D, Harry and Potter.
Harry and Potter.
Harry Potter. I think that option can be ruled out pretty easily. And I'm getting a lot of answers. If people watching on YouTube, we can put in YouTube chat as well. I'll be able to see it as well. And that is right. The option is A, Peter and Gary. That is the right option.
Yes.
And Comet BB here refers to Comet Bernardinelli Bernstein, has a coma, has a moon, or a tail, or tails. Your option again. Which do you think is the correct answer? I see most of you are saying D, that is tails, but actually it doesn't have tails because it's really far away yet. It's still 25 astronomical units away from the sun. It hasn't developed tails yet, but it's actually developed a coma. There's like the little fuzzy area around the nucleus of the comet. So option A is the right one. If you don't know, that's fine. You have learned something new again. So
tail is also a sensible answer because we learned about ion tail and dust tail. So that also, whoever answered D also applause because you guys listened to the nice.
And right, we're getting a lot of answers for this question, which is the biggest comet. B is coming. That is right. Comet Bernstein. We have discussed about this entire comet in this entire presentation. So I hope everyone has got that point. So open-ended question. Did you enjoy and learn something new from the session? Put it in the chat. And thank you.
Well done, well done. So there are a lot of links, 3-4 links I shared in our chat box and also in live. So you can click on it, something like the skylive.com and the one more thing, the stream, the stellariumweb.org. Both are like amazing websites to know about the night sky and comets. Well done, Kashika. So let's give a huge round of applause for Kashika. All of you go unmute. Unmute. I'm going to click unmute. Okay, on the count of 3, we all go clap. We all clap. Okay, ready? 1, 2, 3.
Very good presentation.
Beautiful presentation. I really liked it because a lot of information, including accessing to the night sky, accessing to the comets, accessing to the lot of things. And we learned about the ion tail, dust tails, how it forms, the orbit of comets, a lot of things. So it's like a master class, literally a master class. Well done, Kashika. Super. Thank you so
Thank
much.
you.
And well done. So, okay, next, let's welcome our second presenter. That's Riyansh. So, those who are following Vaayusastra, you may be knowing Aerospace Now. If you know Aerospace Now, you definitely know the CTO of Aerospace Now. That's Riyansh. And he is a grade 8 student from Avalon Heights International School. And he always comes up with unique and new topics. Again, today he comes up with one very new term, like lithobraking. I have no clue what is lithobraking. Let's ask Riyansh. Riyansh, the stage is all yours.
Thank you, Jagu. Now I'll share my screen. Jagu, you can see my screen, no?
Yes.
Yeah, so hi everyone, it's me, Riyansh Vora, the CTO of Aerospace Now. And today I'll be speaking about a topic called as lithobraking. So today we will be seeing a few things. I've not created a very long presentation on this, which will include what is lithobraking, how does it occur, spacecrafts in which it has already used, the problems faced in lithobraking, the real life applications, what is the future scope, and then we have a quiz.
Nice.
So now let's see what is lithobraking. What basically lithobraking is. So lithobraking is basically a landing technique used by unmanned space vehicles to safely reach the surface of a celestial body while reducing the landing speed by impact with the body's surface. So the terrain of some planets or some celestial bodies is very rough. So what the unmanned spacecraft does is it develops such air structures like a ball of air all around it, so that there is no damage to the parts of the aircraft when it lands, and it lands successfully on the ground. So now let's move on. How does it actually occur? How does the spacecraft perform it? So there are basically three steps in how it is done. First of all, protecting the probe with sufficient cushioning, with the cushioning sort of those, you saw those balls, those woolen coverings which cover it. So you need to withstand an impact with an hard surface. So like suppose if you are like to fall, when you fall you need like, suppose if you're falling, you fall on a soft surface, there's a cushioning all around you. If you fall on a bed, suppose you fall on a floor and fall on a bed, the impact is safer on a bed that rather than when you fall on a floor. So this is what there should be less impact and there should be no damage to the spacecraft. There should be only damage so right while you again the spacecraft takes off, it will have no problem and can come back safely to the earth. And there's also like high umbrella like aerobreaker with combination with very shock absorbers. Like see, when you land like this, there's a thrust created and there's a shock over here. Like even if you travel by a plane, when it lands you feel a slight shock when the tires touch the ground. So that is where it should be shock absorbing. So and then next is making incoming angles shallow enough so that the impact has the characteristic of a glancing blow rather than direct impact. So it should land in such an angle so that when you land, there should not be a direct impact with the ground. It should be a slight impact. The impact should not be that strong with the ground and not that direct. Now moving on, it's just like a brief summary of what I told. Lithobraking is typically accompanied by the use of other techniques like retro-rocking braking and use of heat shield and parachutes to reduce speed prior to impact. So lithobraking, you cannot use it individually. You need to use several other techniques along with lithobraking. So one is retro-rocket braking, which is not that commonly used. Heat shields are used moderately, and the most common is parachutes. The image which I showed you, that parachutes are the most common way in which lithobraking is done. So now I will tell you spacecraft. There are 3 spacecraft basically in which it has already been used. So now let's see which are they. So the first one is Soviet Luna 3, this one, Mars Pathfinder, this one, and Verena 9. These 2 are both from USSR, while this one is from NASA. Your Soviet Luna 9 and Verena 9 are from USSR, Soviet company, and this is from NASA. So now I'll tell you briefly about how did Soviet Luna 9 and Mars Pathfinder actually do this. Like how was it performed? I didn't get much information about Verena 9, so that's why I didn't put anything about it. So basically, what happens is the lander had a mass of 99 kilograms. It used a landing bag to survive the impact speed of 22 kilometers per hour, which is comparatively very low speed. It was a hermetically sealed container with radio equipment and a program timing device, heat systems, scientific apparatus, power systems, and television system. So these are all the important parts which could not be damaged, because then it would lead problem when the spacecraft it had to be taken off again. So Luna 9 was the 12th attempt at a soft landing by the Soviet Union, as I told you, and the first successfully land the spacecraft using lithobraking airbags accompanied with retro rockets. So this was retro rocketing used, and it was the 12th attempt of a soft landing and the first Soviet rocket to land down. And at 25 kilometers above the lunar surface, the radar altimeter triggered the jetson of the side modules, the inflation of the airbags, and the firing of the retro rockets. So at 25 kilometers above the moon surface, the radar altimeter started all the processes, like it triggered jettison of the side modules, inflation of the parachutes or airbags, and firing of the retro rockets, which protected from landing. So at 25 kilometers, so far above, the process actually starts, so that you can slow down the speed as you come down, and then finally it stops. You can actually get a soft landing. And approximately 5 meters above the lunar surface, a contact sensor touched the ground, triggering the engines to shut down. So a sensor actually programmed it and shut down the engines, because this sensor program is recognizing the landings soon. It shut down the engines and the craft landed at 22 kilometers per hour speed. Now let's look at how the same happened in Mars Pathfinder. So Mars Pathfinder entered the Martian atmosphere and landed using an innovative system involving an entry capsule, supersonic parachute, followed by solid rockets and large airbags to cushion the impact. So the Mars Pathfinder directly entered Mars atmosphere at 6.1 kilometers per second. The speed was too high comparative to what Soviet Luna 9 entered. A supersonic disc gap band parachute was inflated to its slow descent to the matter through the thin Martian atmosphere to 68 meters per second. It was reduced. The the parachute reduced the speed to 68 meters per second. Once the land was 355 meters above the ground, the airbags inflated. They inflated in less than a second using 3 kinetically cooled solid rocket motors that served as gas cylinders, so which produced gas, which lowered down the speed because it created a friction which would slow down the speed of the rocket. And the airbags were made up of 4 interconnected multi-layer Vectron bags that surrounded the tetrahedron lander. So the veteran bag surrounded the ladder, which could slow down the impact. The lander impacted at 14 meters per second, just such as less speed. It limited the impact to only 18 gram of deceleration. So what happened is only 18 force of gram of deceleration was produced, and the first bounce was 15.7 meter high. So it bounced back 15.7 meter in the sky and then continued bouncing for at least 15 additional bounces. Because like see, even if a ball falls down, it bounces and then stops finally. So this is what happened in this case as well. So now there were some problems faced. Even though the landing was successful after some time, initially there was some problems faced, and even when it landed, there were some problems faced. Now let's come. There are only major 3 problems which I'm going to discuss about. So lithobraking as a method of deorbiting a spacecraft has not been used due to the extreme high orbital velocities of most bodies. So most celestial bodies have high orbital velocities. So it cannot be used because these high orbiting velocities will not decrease the speed of the aircraft to that extent. And then maintaining shallow incoming angles is very difficult. And small trajectory changes can lead to ricocheting or accelerating free fall at steep angles. So like maintaining shallow angles to prevent the impact to be very strong, it's very difficult. And small changes can lead to ricocheting of the rocket or free fall. It can lead to speed of the aircraft accelerating so much, you can just fall down like that. It's a free fall. Like when in bungee jumping, what do you do? It's a free fall from the mountain. That's what is going to happen. And lithobraking is also sometimes used as euphemism to describe situations in which lithobraking was not the original desiring landing method, that is crashes. So in crashes also what happens is when it's about to crash, you're not supposed to use lithobraking to land. But when it is about to crash, what happens is when it crashes, automatically the spacecraft releases the parachutes, which leads to not required lithobraking, which is not desired lithobraking, which is also a problem because then putting back the parachutes inside is also a very big problem. It's a very tedious process, takes a lot of time. So it's very time consuming. That is why also. So the applications. So some small moons and asteroids have very low gravity, but lithobraking can conveniently be used. In small moons and asteroids, you cannot actually land the normal techniques because what happens is the surface is very rocky. So it can lead to some amount of breakage or damage to the parts. And next is lithobraking can be used for supply drops on different planets where cushioning care packaging is dropped from an orbiting spacecraft. So sometimes what happens is fuel packages, food packages can be dropped for the astronauts so that they can get food if there is a food scarcity. So this is a very important usage of lithobraking, so that an external aircraft can be sent. It doesn't land on the atmosphere of the celestial body. It has just entered the atmosphere. It sends down the passage. It drops the package, and the astronauts can easily receive it as it lands down, along with the parachutes. Next is the incoming velocity can be used to enable the probe to penetrate the surface of a moon or an asteroid easily. That's what I told. The decreasing velocity can be used to easily to penetrate inside. Now, what is the future scope? The last topic was what is the future scope? So, certain concepts in the spacecraft in an orbit tangent to the surface of the body in question are in docking with a magnetic levitated train, maglev train, and then the train slowing down. So it is related in a way that in the atom in this the initial speed of the space rocket is very high, but it decreases drastically. That's what happens in the maglev train. It travels at a very high speed, and when a station is about to arrive, they just deactivate the magnets. So the repulsion becomes drastically slows down. That is why what happens is it slows down drastically. So this is how it is related, and this qualifies lithobraking as the reaction mass in the is the planet itself. If the reaction what is going to take place, the bounce is going to take place is the planet itself. It's not going to take place on any other additional surface. And this technique requires extremely precise guidance and control in addition to large infrastructure, and it is thus not a viable option. Although it may be in the future, an advantage to this method is can also launch spacecraft without needing any propellant. So, suppose without propellant also it can be used in the case that retro rocket can be used to power the aircraft to retro rockets and parachutes can be used by the aircraft to like just increase the speed. Retro rockets can be used to increase the speed and then to control the speed and to launch it more further. You can use all the other types of heat shields and all of that to just prevent the speed. But nowadays, as I told, as it is written over here, nowadays it is not used that widely. But in the future, it will not when we'll have to transport very vital things to the different planets. If we start colonizing it may be useful. Now I'd like to end my presentation with the quiz which I've prepared.
It's a brilliant presentation. I have seen this kind of landing in one of the NASA videos, the Spirit landing. Maybe we can, if we can find that video, we can play it. Riyansh, you want to play it and show to audience?
Yeah, Jagu, wait.
Yeah,
and
yes.
then I'll end the first should I make the quiz, Jagu, then I'll share it.
Yeah, okay, now let's finish the quiz first. Quiz time. Posting this.
Jagu, I've got the video. Sanish.
Sure. It's like I was thinking Chandrayaan, that crash happened. I was thinking why India did not use this technique. So I have seen this. We have seen this few times, but I did not know the exact term. Lithobraking. Yes. Okay, first step. Lithobraking. I think this itself can become a separate startup idea. Lithobraking systems, because it has a lot of applications in future. Not only in Mars or Moon, even in Earth itself, it has a lot of
Jagu,
applications.
I have some ideas about another presentation about this.
Nice.
Jagu, I'll start.
Yes. Lithobraking is a landing technique used by vast space vehicles to safely reach the surface
Fill in the
of a
blanks.
celestial body. Unmanned space vehicles are
So who got it right? Let's check.
Adrit.
Adrit got it right. Only Adrit got it right. Okay.
Balloon
Question?
physics. Lithobraking is used along with which of the following other two techniques? Retro rocket braking, use of heat shield, use of landers, retro rocket lander.
There are two options.
Yeah, you can choose two options.
Six people choose use of heat shields, and people got confused between retro rocket landing and retro rocket braking.
Braking.
So it's retro rocket braking, not landing.
Lithobraking was used in which of the following
Guys, there are
aircrafts?
two options. Two options. Select two options.
Oh, Venera 9, Mars Pathfinder, Soviet line, Soviet Yanta, Soviet Lone.
People knew about Mars Pathfinder, but very nine people, very less people chose. Guys, have to select in kg as well as LB. There may be two options, I'm not sure. Maybe two options.
Okay. 99 kg and 218 pounds.
So these two were the correct options.
Lithobraking cannot be used to land spacecraft on asteroids and moons. True, false, maybe true, maybe false.
You know, and I don't know. So I think everybody might have got correct. Good. Only one person got false correct. Guys,
They got confused with the question.
Lithobraking cannot be used, not lithobraking can be used. This is the gold top. And for people who understood it mostly, the next question is very suitable.
Type in your doubts. Okay. Not applicable.
These were the two people who answered. Now you
Hey,
don't,
ask your doubts.
or you can, Jago, if you don't want to ask publicly, I'll send my email ID. They can mail it to me.
Yeah. Yes. Overall, they might have got an idea what it is, but in depth, they definitely need your help. Let's see who is the winner. Matesh, Adrit, and Tarun.
So
Well done. Super.
now let's see the toughest question.
Nice.
This was nobody got both the options correct.
Okay.
Which was the longest question? Wait. This is the toughest as well as longest question.
Okay.
Okay, good. Now I'll stop sharing.
Nice.
Share
Well
this.
done.
Jagu,
Well
can you
done.
hear me?
Yes, yes.
Jagu, you told that about that spirit rover. No,
No, that he will show. Now he will show down.
no, I have already got that video.
Okay. Play it, play it.
Yeah, Jagu.
Maybe from the half. Ah. Okay. இது போதும் இங்க இருந்தே இருக்கட்டும். Let it.
Landing part.
Yeah, now it's entering into the Mars orbit.
Just passed 1 minute to atmospheric entry, current altitude 121 miles, current velocity 12,084 miles per hour. We are now at an altitude of 73 miles, moving at a speed of 12,192 miles per hour. Expected parachute deploy in 5 seconds. 4, 3, 2, 1, mark.
So this is the first
We're awaiting confirmation.
thing to reduce the velocity. We're opening the parachutes.
Parachutes been detected.
First method to reduce the velocity of the re-entry vehicle. Now second,
Int'l deployed event. Spacecraft reporting
The airbag.
Airbags, yes.
separation event has been detected. Spacecraft reporting lander is separated, moving at a speed of 173 miles per hour. We are near our terminal velocity.
there it go.
Retro rocket
Got cushioned up.
mark.
Yes. Can you see retro rocket? This is the retro rocket.
Speeds. Will jump.
At this point in time, we should be on the ground.
Oh. It is like some one-story building football jumping.
The vehicle would be alive, on the ground and bouncing. The spacecraft has to survive all the bounces or landing be a success. No signal at the moment. Stand by. Signal strength is currently intermittent. We don't see a signal at the moment. Right.
Now the balloon has to go deflated.
To deflate. If you don't deflate, it will be a
Yes.
problem.
Yeah,
What do we see?
they got the signal. Wait for it.
Deflating the balloon.
Ah,
It is
super. Beautiful. So India would have tried this method now for Chandrayaan.
Then it would not have crashed.
Nice.
These are the image I showed you in the
The first thing we have to do after we land is open our solar panels to the sun so we'll have some power. This charges up the batteries. After that, we can deploy the camera mast so the rover can see, and deploy the antenna so the rover can talk to us.
Beautiful. Nice. Beautiful, beautiful. Well done, well done. So, right, superb topic, Riyansh. So, lithobraking, something a new term and the new technique. I think we went through in detail. Nice. Thank you so much. All of you go unmute. Let's give a huge round of applause for Riyansh. All of you unmute yourself. Ready? 1, 2, 3.
Sir, it's coming that stream unavailable, sir. It's coming stream suspended.
What happened? I don't know.
Sir, so
Jagu, it's
watching the stream,
going.
sir.
What?
Jagu got suspended, Jagu.
There's
Suspended
someone.
in this.
Sir, I was seeing this video, sir, and then suddenly I saw it suspend.
It's suspended.
By policy
It's-
violations. Oh, because of this video?
Yeah.
Maybe. I don't know. Okay, let's continue.
Sir, but now all the users and now it is removed.
Or the whole thing removed?
Yeah,
I don't know.
Jagu.
No, Jagu. It's there.
Sir,
It's
it's
there.
removed, sir, but it'll come unavailable. It'll come unavailable. Even though it's live, it'll come unavailable.
Yeah, Jagu, work,
Sure, sure.
but here only it won't come.
Okay, okay.
Yeah, that last after
Yeah,
that
like you said.
spirit rover.
Okay,
this
okay.
thing
Sir,
No
because right
issues.
now it's live, sir. After it's fully done, sir, it will be completely removed. If you
No,
end the
yeah,
stream,
that we can see it. That we can see to it.
Jagu,
Anyway,
I
he's
think so. நம்ம வந்து நமனா அடுத்த வாரம் திருப்பியும் present பண்ண சொன்னோம். Because live stream போயிருச்சு.
Not Jagu.
yes, sir. It is a. If you, it's a. Yes, so the live stream might end, sir, because if the strike and all comes, sir, I don't know.
And Jagu, திருப்பி ஆரம்பிச்சுன்னா we also tried a live stream once, but என்ன ஆயிடுச்சுன்னா நாங்க ஒரு தடவை நாங்க வந்து இங்க டார்கெட் பேஜ் யூடியூப் சேனல்னு போட்டதுனால
okay. Wait. Anyway, let's try continuing.
Okay, sir.
Let's see.
Sir, I was working, sir.
It's working. Okay, super.
Yeah, it's now working.
Now working. So only that part of the video. That's fine. I'll remove it anyway. So don't worry.
Sir, I said they only removed.
Yeah. Okay, no issues. Okay, next. Well done, Riyansh. Anyway, so that is lithobraking. It's a new topic, new science content, which is presented to all of us. Thank you so much. Now let's welcome our next presenter, Naman. So Naman, those who are following Vaayusastra will definitely know Naman. He's a grade 5 from ekya school. He is also now, and he is going to present on this topic. It is not as part of a series, but it also related to a series. Which is better, going to another planet or making Earth better place? Okay, let's see what Naman brought here. Okay, Naman, you can start.
Okay, so thank you, Jagu. So let's continue. I'll just share screen. So can everyone see my screen?
Yes.
Yes, Naman.
Okay. So which is better, going to another planet or staying and making the Earth a better place? Well, Jagu, I'm having a bit of trouble.
We can see it. So we can see the presentation.
Okay, sorry, Jagu. Oh, it started again. Wait, let me rectify it.
Yeah.
Okay, now it's better. So I'll continue now.
Yes.
What would okay, just sorry. So what would happen if we were to live on Mars, which we know is the most common, most like famous candidate of colonization. So indeed, it's the plan of many space organizations to send astronauts to Mars. It would be an achievement, of course, but some space organizations, probably most now, have the plan to colonize Mars and make it humanity's new home. While the Earth starts getting perished because of us. Well, for now it's hardly possible to live on Mars because of the extreme temperatures, the constant radiation, twists in atmosphere, and a lot of the reasons. But space organizations will not just give up. They will find ways to, you know, uh, try to colonize it with all suitable conditions. Now, one more candidate, Titan, which is Saturn's largest moon and the second largest moon in the solar system. So, what would happen if we lived on it? So, we have probably heard of this mission, Cassini-Huygens, which is basically a mission to explore Saturn, and it has taught us a lot about Saturn and its moons. Obviously, Titan is one of them, and now scientists believe Titan has the needs that humans require to sustain. Thus, it may be possible to live on Titan because we have found remains of liquid water on the area. So, but the answer is still remains undetermined because right now many people are focusing on Mars, very few people are focusing on Titan, and yeah, other candidates remain undetermined. So, space organizations are trying to colonize Titan in the background, while Mars colonization is the foreground. As I said, some say to leave Mars and colonize Titan, while some say to colonize Mars anyway. But we can do both. Two birds, one stone. So, the other side of our decisions, what about making Earth a better place? Some don't even want to colonize planets and rather choose to make Earth a better place. We still have that moment to change Earth the way it is. As you can see on the right image, the right side of the right image, you can see how it's going to become if we don't keep it safe, and the left side of the right picture shows what will happen if we maintain it. So it would be great, obviously, since we won't have to spend billions of dollars on space probes, spacecrafts to make sure, planets are sustainable, even moons. I won't forget about Titan. But the easiest thing we can obviously do is just plant a tree every single day and make sure they're maintained. And that would help, obviously. In fact, trillions of dollars go into cigarettes and tobacco. Every year, more than $3 trillion goes to tobacco and cigarettes. I'm not even joking. Not lakhs, not millions, not crores, not billions. Trillions of dollars. Oh, I'm asking you one question. Why don't we plant trees? Because there are only 3 trillion trees, out of which we probably cut 50,000 a day. So if you do the math, we probably would make trees completely extinct in maybe 1,000, not even 1,000. If you think of it, 1,000,000 years, trees would go extinct. So
Yeah.
if we would have spent this money on trees and other development things, we probably would have 7 to 8 million trees, trillion trees, less plastic in the oceans and whatnot. So colonizing other planets. Yes, for now, Mars and Titan are the main targets for space organizations, but don't think they can and be to be colonized. The only two. As in my these plans of the solar system and beyond, I have introduced a lot of planets that are actually colonizable. because they have liquid water, sustainable temperatures. So we could be able to colonize planets, but for now we have no other clue. At some point, we may colonize interstellar planets anytime. We know the universe is a very huge place. We never know when we can do what because of a quick development in technology. 5 years ago, Sophia came out, and now in 2022, you can see the world. There are some schools which have robots teaching instead of teachers. So, what if we didn't colonize? Well, we won't live long enough if we won't colonize another planet. Why blame yourself? Humans made a beautiful planet to garbage. I'm not even joking. We have this form of selfishness that led us to this. And I don't even feel bad for saying this. It's the truth, it's reality. So if we don't switch planets, mankind may go extinct along with plants and animals. It's a do or die challenge now. Well, if we hadn't done all of this, there was no requirement to spend millions, not even millions, billions of dollars on this colonization mission. So what do scientists think? There are a lot of debates on whether to make a better place or colonize. Scientists believe that it would be better to make Earth a better place. It's because some believe that humans will also pollute Mars or any other colonized planet. On the other hand, scientists believe that colonization should be done because they think humans require another planet to sustain more generations regardless. So what do you think? Should we colonize other planets and moons, or should we make Earth a better place as it was a few decades ago? Thank you.
Awesome presentation, Naman.
Topic to be discussed.
Simple topic, but a good presentation.
We spend trillions of money to colonize other planets. Most of us tend to forget what we are doing to Earth. Yeah. Yes. We need to save Earth as well.
Yes, sir. Actually, sir, if we like spend the amount like we are spending on the space, we are spending that much money only, I guess, so Earth will
Will
become
help
proper.
only during the time of so it help only when during the time of some catastrophe or some asteroid hits during that time to save humanity. Only it works. So nice. So well done, Naman. Superb. Thank you so much. So you have any, Naman?
Is there quiz?
What, Jagu?
Do we have quiz today?
No, Jagu. It's
Okay,
15
done,
so
done.
we can't say.
Super. No issue. Our presenters were extraordinary today. So if you take about comets or you take about lithobraking, presentation, then they delivered, very confident. Well done, super. So let's give one huge round of applause for Naman and all the presenters. All of you go unmute. Ready? 1, 2, 3. Yes. So much of learning happened today. Be comments or let's be this lithobraking or regarding the thought about. So well done. Thank you so much, all three of you. Naman, glad we had this today. Yes. All three topics are like the professional, the experience I can see here. It's equal to college level or even better college. Thank you. So all next week with new set of presenters and new set of topics. Thank you all. Okay.